Hello students, today's question is x square plus 2x into dy by dx plus 2 times x plus 1 into y equal to 0 with the initial condition y of x0 equal to y0. So this differential equation has infinitely many solutions with the given initial condition. There are four options: y at x equal to 0 is 5, y at x equal to 0 is 1, y at x equal to 2 is 1, and the last one is y at x equal to minus 2 is 0. Now let us discuss few methods to solve first order first degree ordinary differential equations when we solve this differential equation. Dy by dx is equal to say f of xy. Then we have different methods to solve the differential equation, in which the first method is separation of variables. Separation of variables. What we do in this method, we collect the terms which has x variable, we collect the terms which has y variable, and we separate out the terms of x variable and y variables in this way. So I have some quantity f1x into dx, and I have something say g1y into dy, and then we integrate this equation with respect to x and with respect to y, and we will have the solution. Keep in mind, when do we solve the system of linear equation, the solution is known as the family of curves. Family of curves means what? If we solve this system, if we solve this differential equation, so this differential equation contains first order derivative dy by dx. So when you integrate this, it has one random constant. So when we choose the different values of that constant, we have the different curves. All the curves are having the same nature. That's why this solution is called, or the set of solution is called, the family of curves. Family because of all the curves are having same nature. Suppose the differential equation has solution x square plus y square equal to c. Suppose c is 1, then it is circle with center 0 0, radius 1. Suppose c is 4, then it is circle with center 0 0 and radius 2. So when we choose the positive values of c, then it represents the circle with center 0 0 and different radius based on the value of c. Right. So all the curves are circles. Right. That's why they are known as the family of curves. So this is the one method to solve this differential equation, separation of variable. Another method we may have is we convert the given differential equation into linear form if possible. All the differential equations will not be of this form, keep in mind. Dy by dx plus q of x into y is equal to q of x. And what is the solution of this differential equation? To solve this differential equation, as you know, first we find integrating factor. What is integrating factor? Is known as e raised to integration p of x dx. As the solution yx into integrating factor, which is equal to integration of qx into integrating factor dx. So these are two different methods, separation of variables and first order linear differential equation which has solution in this form. Now let us refer one more method. So here I convert my given differential equation into this form m dx plus n dy equal to 0. If the differential equation can be represented by in this form, then I check the derivative of m with respect to y and the derivative of n with respect to x. So derivative of m with respect to y is same as derivative of n raised to x. Then this is called exact differential equation. And this is very much important quantity in engineering. Right. Once my differential equation is exact, how do I find solution? I integrate m with respect to x plus I integrate and with respect to y and equal to some constant c. The constant is always real. Now, when I integrate m with respect to x, m contains both the variables x and y. So here my assumption is y is assumed as constant. And here this is not actually only n. So what is this? This is n1 where n1 is derived from n is such that n1 contains the terms which do not contain x. That means I have to choose only those terms from n which do not contain x. This differential equation m dx plus n dy equal to 0 has some importance. So let me discuss that importance here. Now see, I am saying that this differential is exact. That means del m by del y minus del n by del x equal to 0. That is the meaning del m by del y equal to del n by del x. So what I am saying, del m by del y minus del n by del x is equal to 0. Now let us recall something which is related to Green's theorem. In Green's theorem, what I have given? I have given the vector field over the closed curve C and I am integrating it. That means actually I am finding out this this you may say this is the work done or path integral or the total work. If this region has fixed direction, then you may say this is the flux also. This represents the rotation also. So this is equal to, by Green's theorem, you are solving this double integration over R del m by del y minus del n by del x dy dx, where I am assuming that my vector f is this form m comma n. Right. So now this quantity vector f into vector dr has this representation. What is my vector f? M and n. What is dr? Is dx comma dy. So this is actually m dx plus n dy. And you observe that m dx plus n dy is here, m dx plus n dy is here. So whenever I am integrating this quantity over some closed curve, right? That is what I am solving this m dx plus n dy, right? So I am integrating this also over the closed curve C. You may think like this. This is equal to integration over C over some closed curve, right? That means while you are solving this system of linear equation, actually you are solving this one. Clear? Now the geometric interpretation is, what is this quantity del m by del y minus del n by del x? So del m by del y minus del n by del x is known as the curl of this vector f. And what is curl? Curl is known as the rotation in vector field. Now when I say that del m by del y minus del n by del x equal to 0, that means I am saying that the curl of this vector field is equal to 0. Right. Now the curl is 0, that means the vector field is irrotational. So what do you mean by the vector field is irrotational? The corresponding differential equation is always exact. So this is how we are comparing the exact differential equation and the curl of vector field Mn. This geometry is always important to understand. Now let us go back to our question. Now let us try to solve it. So out of these four methods, this is the question when you can apply all these three methods: separation of the variables, linear differential equations, and exact differential equations. Here I am discussing the solution with separation of the variables, because easily I can separate variable x and variable y. So dy upon y is equal to, I am writing 2 times x plus 1 divided by x square plus 2x into dx. Now I integrate this quantity both sides. When I integrate this quantity both sides, what do I have? What is the integration of dy upon y? You know that integration is ln y. Now what is the integration of this quantity? So what is the derivative of x square? Is 2x. And what is the derivative of 2x is 2. So the numerator is 2x plus 2, denominator is x square plus x. So if I assumed that my x square plus 2x is capital X, then this 2x plus 2 is my x dash. So actually this is the quantity x dash upon x, which has integration ln of capital X, and capital X is x square plus 2x. I write the arbitrary constant where c belongs to R. Let me write the arbitrary constant in terms of, say, logarithmic function, where c1 is, you may choose with some appropriate c1. Then what I have, ln y is equal to, this is ln a plus ln b, that can be represented by ln a into b, right? If I remove ln from both sides, that means I am taking antilog both sides. So I have y is equal to c1 into x square plus 2x. Now I have given these four conditions, and out of these four conditions any one is the solution, right? So I need to check that this solution satisfy which conditions. So let me start from option A. So my option A is when x is equal to 0, the value of y equal to 5. So if I substitute x equal to 0 here, then this is c1 into 0 square plus 2 into 0, which is 0. And the left hand side, when x is equal to 0, what is y? Y is 5. So 5 equal to 0. This is not possible. That means option 1 is not our solution. The next condition is condition number B. The next condition is when x is equal to 0, y is equal to 1. So when x is equal to 0, I have y is equal to 1. So when I substitute x equal to 0, this is 0 square plus 2 into 0 is 0, which is equal to y is 1. So 1 equal to 0, again not possible. Now option number C, when x is equal to 2, y is equal to 1. So when x is equal to 2, y is equal to, so we have 1 is equal to 8 times C1. And so what is C1? C1 is 1 upon 8. Okay, we have the value of C1. So when I substitute C1 is 1 upon 8, that means I have y is equal to 1 upon 8 into x square plus 2x. My requirement is infinitely many solutions. So y equal to 1 upon 8 x square plus 2x from the option C is not the solution. So now we have only one solution that is remaining. Therefore the answer must be D. But here we need to understand When x is equal to minus 2 square is 4 plus 2 into minus 2. That means this bracket quantity is 0 into C1, which is equal to y is 0. So what does it mean? 0 is equal to 0, which is always true. But I am not interested in this. 0 equal to 0 is true, that we know. I am interested in this equation. What information we have from this equation? 0 is equal to C1 into 0. What is my C1? C1 is any appropriate constant. That means if C1 equal to 1, then also this is true. When C1 equal to 2, then also this is true. When C1 equal to 3, 4, 5, that means I can choose any value of C1. Suppose C1 is say 1, 2, C1 is pi, C1 is square root 2, even more, so C1 is 5.7 or any large number. So for any value, appropriate value of C1, this satisfies the equation. That means this condition is option D is my appropriate condition for which the system has infinitely many solutions. Now, if you look at these four options, then option number 1 and 2 are informing us that phi equal to 0 and 1 equal to 0 are not the possible equations. So, the initial condition A and B are not valid initial conditions. Condition number C is the valid initial condition, but it has unique solution, and option number D is also the valid initial condition, but for which the system has infinitely many solutions, and here our answer is D. I hope you like this video.